In today's video, I want to talk about analytic functions. These are functions that were added to SQL, maybe 10, 15 years ago. And they are really powerful tools in doing analysis on data. Before these were available, we needed to actually write code to do to implement the same functionality. And what they really allow you to do is perform analysis, particularly on time series data over time. And they can identify things like gaps, islands, concentrated data, and doing things like looking back and looking forward within a data set so that you can do calculations. So let's take a look into some of the details here. So some of the things you can do is you can rank and filter. So some functions are like row number, which actually give you a row number within your virtual data set. So what you can do is create little partitions in your data and then perform calculations based on those mini calculations. So for example, let's say I have a particular stock that I'm tracking. My database has data on thousands of stocks, but I want to actually do calculations on each individual stock. So I want to look at maybe a price series, time series. And so I have data in my database with all prices over time for all these different stocks. And what I can do is create a little data set for each stock individually and then do calculations on them. For example, let's say I was tracking Amazon stock over time and IBM stock over time. So in both cases, I'm really interested in the price time series for them individually, and I don't want to combine everything for IBM and Amazon into my analysis. And so what I can do is create partitions in the data. And we're going to take a look at this in some examples in just a bit here. So some other things you can do is perform running totals. So let's say I'm querying on orders or something like that. I can sum up all the orders for a particular customer over time. And I can do that all in one query. I don't have to do it in multiple queries for each customer I have. I can do everything in one shot, which is very performant. And then I can do things like lag and lead, which allow me to look back and look forward. And so like for the examples with the price time series with the equities, I could look at yesterday's price and I could look at the day after today's price. And what this allows me to do is compute things like percent difference or difference between the prices. And all sorts of things can be done on top of that. So some other things we can do using lag and lead is look for gaps. So I can say, okay, well, let's say I'm looking at a price time series and I have a price for today and I have a price previous to today, but I don't know exactly what day that was. And so I can look back and say, okay, well, the date of the previous price I have in my time series is from a week ago. Well, maybe I'm missing data then. And so I can say, well, whenever I have a difference between yesterday's price date and today's price date, more than 3 days to account for like weekends, well, then I have an anomaly I need to look into. Some other things I can do is interpolate data. So a couple of functions we have available to us are first value, which identifies the very first value within the local partition for each data set I have, each mini data set, as well as the last value in there. And so I can do things like interpolate data because I've got 2 points and I can draw a line and then try and figure out where things fall in between. And I can analyze patterns by looking for things that fall outside of those patterns. We already talked a little bit about detecting, islands and concentrated data. Again, we do that with the lag and lead functions. There's also like some density functions that show us how dense data is over time. And we can investigate causes of problems by having these tools available to us. So some advanced analytic functions can do trend analysis. So there's actually functions that we can look at like the slope of a line or the y-intercept using the regr slope and the regr intercept functions. We already talked a little bit about first value and last value. These can be used for things like seasonality and detecting patterns using these functions. And for anomaly detection, there's also standard deviation functions that are available. The way we segment all of these mini partitions within our result set is using the partition by and case statements, and we're going to look at some examples of that. These really can improve efficiency. So like I said before, we had to write code to do this stuff before. So if I want to do an analysis on all the stocks in the S&P 500, I would have to write code that would go through, and for every individual stock, we would need to perform the analysis, and that would be done in code, and we would pass like that particular stock into the function. It would do these calculations based on that using the data, and then come back and return it. So we'd have to write code to do that. We no longer have to do that with analytic functions. They're also very flexible. Like I said, there's a lot of different options available, a lot of functions that are available in the analytic function tool chest. And these provide insights, and because you can really detect a lot of patterns and trends by looking at your data using these functions. So here's a list of some of the functions that are available. So we've got the row number function that just gives us what number that in sequence it is in that mini partition that we're looking at. We can get a ranking. We can get a dense rank. We've already talked about lag to look back to the previous value or look forward to the next value. Let's get the first value in the sequence, the last value in the sequence, and then we've got some slope and intercept functions that are also available. So now we're going to take a look at some examples. So we've got a table here. We're going to name it equity prices. We've got just a numerical unique ID, equity ID that identifies the particular security we're interested in, the equity, a symbol, price date, which is the date the price is effective for, and then a price. So here's an example of an analytic query. So we're just selecting the fields in the table first, but now we're going to start using these functions. So here's an example using the syntax of the lag function. So we're going to call the function, and we're going to tell what we want the lag of. So in this case, we want the lag price. And we're going to partition by the equity ID. So this is the magic. This is what aligns everything. So for everything for Amazon would get aligned into its own partition, and everything for IBM would be aligned in its own partition. And so that's how everything gets organized. And then you have to tell it what the order is. So in this case, we're saying that we want to use the price date column as the ordering column for our mini data set. And then we can say, we have to give it a name. So in this case, I'm just making it simple. I'm saying, hey, this value that gets output here is the lag price. So just to give a real simple example. So today is 10:15, and we've got a price, let's say, of 10. Okay, and let's say we've got the 16th of October and the price is 11, and we've got the 17th of October and the price is back down to 9. Okay, so what we're doing here is we're getting these in sequence. Okay, and again, this is for let's say Amazon. And let's say we've got another data set. I'm just going to copy this. We've got another set for IBM. And it's going to have its own prices. And, you know, of course, these are purely fictional prices. I'm just giving examples here, but let's say we had 8, and then we had 9, and then we had 10. And so what's going to happen here is that each of these partition bys, it's going to have a different equity ID for Amazon and for IBM. And so their little data sets are going to be independent of each other. So when I look at Amazon and I'm looking at this row, its lag will be 10, and the 15th will be the previous date, and its lead will be the 17th of October with a price of 9. And the same goes true for IBM. On the 16th, its previous date is going to be the 15th, and its previous price is going to be the 8th. And its next, or its lead price, is going to be 10, and its lead date will be the 17th. So that's how this works out. And so we're just repeating that here. We're saying, hey, the lag for the price, and we get the lag price date. And we're doing the same for the lead and the lead price date. And we could do things like the first value. So the first value is going to get us the very first in the sequence. So for Amazon, it will be the 15th of October and 10. And for IBM, it'll be the 15th of October and 8. And we could also do last value, okay? I don't have that example here, but it just follows suit. And so that's how you can use these functions. And you run this and you'll get a data set, and it would show you the data for Amazon and also for IBM. But what you can start to do using something like a CTE is you can do even further up analysis on these. So here I'm just taking, this is just the same query that's here, right? And I put it into a CTE, and now I can do some analysis on it. So now I can say, okay, well, give me the equity ID, symbol, price date, price, and lag date. But I can do things like, hey, take the lag price. So an example of IBM, let's say I'm looking at the 16th of October. The lag price is going to be 8. Okay, and the lag price date will be the 15th. But I can do calculations off of this now. So I can calculate like a percentage difference, right? I could say the price today, and then the price today minus the price of yesterday, and that gives me a difference, and I multiply by 100 to get a percent. And I could do the same thing with the dates. I can do a difference on the dates. I can say the lag price date minus the price date, and that'll tell me how many days are in between those prices, which might be important. You know, if that value is greater than 1, then that might be cause for suspicion, right? You know, of course, equities aren't priced over the weekend, so it might be allowable. But if it's more than like 4, the stock market isn't typically closed for more than 3 or 4 days. So that's a good, definite red flag that you might have a problem in your data. And we could also do just a regular price difference. So that gives you sort of a feel of what you can do with analytic functions. So just a quick review here. Some of the key takeaways is the analytic functions really allow you to do complex analysis on time series data. So this is data that's aligned over time, and you can traverse it and do analysis over that data set. They're also extremely efficient, not only in how they run in terms of how fast they run, but also in terms of how quickly you can develop things, because you don't have to go and write code where you used to have to write it. It is part of the functionality of the database. And these are cross-platforms. They're available on Oracle and SQL Server, as well as some of the open source databases like Postgres. And I believe they've even been added recently into MySQL. So that's all I really have for you guys today. I really hope you enjoyed the video. I hope you got something out of it. Please consider subscribing to the channel and like the video if you liked it, and share it with your friends. Talk to you later. Bye.